Looking at section 5.4, radical equation, we'll just talk about this. A radical equation just means we have a radical x, okay, and we have an equation. That's all that is. As far as an extraneous solution, I just talked about that on the board. A lot of times this is going to happen if I have the square root of x equal to a negative number. You square both sides and you get x equals 9, but this is extraneous because the square root of 9 is not negative 3. The square root of 9 is just positive 3. So this would be an example of an extraneous solution. So we do have to check our answers because we can get these extraneous solutions. So on this kind of problem, this does not work, so there would actually be no solution. All right, so looking at this first problem here, this is an extra one that we're just kind of adding on. It says x plus 1 equals the square root of 7x plus 15. So to solve this, we have to square both sides just like we did in the warm-up. Now, here's what I want to point out, though. If I square this side, it's not just x squared plus 1. What is it if I square that? Right. You have to be careful with that, and you have to make sure that you're thinking of what would it be after we FOILed it. And the quick way is square this, multiply these and double and square that. When you square this side, you just get 7x plus 15. So now solving this, x squared, I'm going to subtract 7x, that's negative 5x. 1 minus 15 is negative 14. Now we set up our double parentheses. And then we get our solutions of 7 and negative 2. We do need to plug those back in to see if there are any extraneous solutions. So if I plug in 7, 7 plus 1 is 8. So when I check this, I'll use this kind of symbols. So I'm checking 7. 7 plus 1 is 8. Does that equal 7 times 7 is 49. 49 plus 15 is 64. And the square root of 64 is 8. So 7 did work. Negative 2 plus 1, so when I check negative 2 plus 1 is negative 1. 7 times negative 2 is negative 14 plus 15 would be 1. Square root of 1 is just 1. Well, 1 does not equal negative 1, so therefore, does that work? No, so this one's not a solution. That's extraneous. All right, questions there? Okay, we're going to do some off of this page. The first two, pretty easy, very similar to what we did in the warm-ups. Do be aware that the cube root can equal a negative. That's fine. It's just the square root cannot equal a negative. So let's look at example 3. So if I want to solve this one, we have to isolate the radical first. So I have to subtract 6. When I do that, I'm going to get 1/4 times the 4th root of 2x equals 4. Now, before I raise both of these to the 4th power, I'm going to want to multiply both sides by 4. So now I'm going to have the 4th root of 2x equals 16. So once I have that simplified to where it's all by itself, the radical is isolated, I raise it to the 4th power here and the 4th power here. So 16 to the 4th power is this, and so I have 2x is equal to this number, and then I would just have to divide by 2. So x would be 32,768. And I could check that, but because there's no negatives that result anywhere, it's going to work. The only time we get these extraneous ones is if we get a negative over here or something like that. Okay, number 4 is pretty straightforward. We're not going to do that one. Okay, what about number 5? The radical's already isolated, so we have to square both sides. So you guys tell me what you would get if you have x minus 7 and you have to square that. Yeah, Zane, what did we get?
X squared minus 14x plus 49.
Good. And then over here we just have x minus 5. Because this is x squared, I want to get this set equal to 0, and then I want to factor it. So again, I want you to try to do this without really showing your steps. negative 14x minus 1x, 49 plus 5. If you try skipping steps and you find yourself making mistakes, then go back and start showing your work again. But you really should get in the habit of not having to show absolutely everything. What are numbers that multiply to be 54 and add to be 15?
Early. No, sorry.
Oh, 9 and 6, right? So we get minus and minus, and so our answer is going to be 9 and 6. Now we should check this. If I plug in 9, 9 minus 7 is 2. 9 minus 5 is 4, square root of 4 is 2, so this one works. Plug in 6. 6 minus 7 is negative 1. 6 minus 5 is 1, square root of 1 is 1. So 6 did not work, only 9 worked. That's another example of an extraneous solution. All right, let's go down here. Let me just show you on number 7 what we would have to do. Okay, so on number 7, if I square both sides, we have to square the 4 and we have to square this. So this would actually end up being 4 squared is 16, and then this would be x plus 1. If we square this, what are we going to get here, Henry, if we square that?
X squared plus 2x plus 1.
Good. So we want to distribute. Now we're going to get this set equal to 0. So all I'm doing is subtracting those. What are numbers that multiply to be 15 and subtract to be 14? All right. And a minus and a plus. And so our solutions are going to be 15 and negative 1. If I plug in 15, that's going to be 16. Square root of 16 is 4. That would be 4 times 4 is 16. And that would be 16. So 15 works. Negative 1 plus 1 is 0. Times 4 is 0. Negative 1 plus 1 is 0. So that worked as well. So we can have 2 solutions. Just because we get 2 solutions does not mean that one has to be extraneous. All right, and then we're just going to do one more, and it's number 10. And this one's going to be a really tough one. The reason it's more difficult is because it's impossible for me to isolate both of these radicals. So I'm just going to have to leave it as is. And I'm going to have to square this side and square this side. Squaring the right side is easy. The radical just goes away, and I get 3 minus x. But squaring this side, I have to think of it like this. I'm actually going to have to write it out twice. Because here's what that actually means. So I'm going to have to do the first times the first. That's going to just give me x plus 7. When I do these outers, I get 2 radical x plus 7. When I do the inners, I get another 2 radical x plus 7. So what's that going to give us? A 4 radical x plus 7, right? And then our last times our last is 4. So I have to isolate this radical. To isolate this radical, I'm going to want to subtract x, and this would be a total of 11. So I want to subtract 11. So what am I going to get if I subtract 11? I have 3 minus 11. What would that be? Negative 8. And then I have negative x minus 1x. What's that going to give us? Negative 2x, right? So now what we're left with over here is just a 4 radical x plus 7. If possible, I would like to make this easier to do. What am I always allowed to do to an equation? Multiply or divide even, right? So what could I divide each of these terms? Here's one term, here's a term, here's a term. They can all be divided by 2. So if I divide this by 2, divide that by 2, and divide that by 2. And now what am I going to have to do? Square both sides again. So if we square this side, 2 squared is 4. We're going to come up here because we're not doing this one. That's 4. Now radical x plus 7 squared is just going to be x plus 7. Squaring this, I can square the first one. That's positive 16. I multiply these two, which would be positive 4x, and then I double it. And then negative x squared would be plus x squared. So finishing this, I want to distribute. What do I do with the quadratic? I want to get a set equal to what? 0. So I want to get a 0 over here. So I'm going to put my x squared first. Then I'm going to have 8x minus 4x. And I'm going to have 16 minus 28. What are numbers that multiply to be 12 and subtract to be 4? 6 and 2, plus and minus. Our solutions are negative 6 and 2. Plug negative 6 back in here. Negative 6 plus 7 is 1. Plus 2 is going to be 3. 6 minus negative 6 is 9. Square root of 9 is 3, so this works. 2 plus 7 is 9. Square root of 9 is 3. Plus 2 is 5. 3 minus 2, though, that's 1. Square root of 1 is 1. So 5 does not equal 1. So 2 is not a solution. Only the negative 6 is. So you hope you don't have too many problems like that, where you have to square both sides once, but then you still have a radical, so we had to square both sides again, and then we had to factor. Okay? Understand the basic idea there? Any questions? All right, so your assignment is up